Welcome back to the Foundry by Forge College. Okay, let's dive into today's explainer. Now, if you remember, in our last lesson, we successfully got all your clusters and wallets wired up. So today, we're putting on our detective hats. We're going to safely snoop around the Solana blueprint and learn exactly how to query account state, without accidentally detonating a smart contract in the process. We're going to see what's actually happening on-chain.
Here is the literal blueprint for what we're covering today. First, the blockchain detective. Then, CLI core query commands, decoding base64 account data, real-world program accounts, building your query script, and finally, next steps and conclusion.
All right, part 1, the blockchain detective, scanning the machinery.
So, now that your wallets are pointed at the correct network, I want you to think of this process purely as gathering intel. You can relax. We aren't broadcasting any transactions or risking any funds just yet. This is strictly read-only state inspection. It's kind of like looking under the hood of a car with a flashlight. You can look in there all day long without accidentally voiding the warranty.
Moving right along to part 2, CLI core query commands, your primary diagnostic tools. Check out this table we've sketched out here in ink. These are our 3 primary tools for extracting the what an account holds and the when that snapshot was actually taken. First up, we've got Solana balance followed by a public key. That's your quick check for SOL. Next is the real heavy hitter, Solana account. This one returns a super rich payload detailing exactly what is inside. And finally, Solana block. The blockchain is literally always moving, so querying a specific block gives you that absolutely crucial temporal context of when that data was true.
Now, here's the fun fact. When we use that Solana balance command, we are actually looking at lamports under the hood. Think of lamports as the pennies to your dollar, except in this case, 1 SOL is a whopping 1 billion lamports. Yeah, 1 billion. The CLI is honestly just doing you a massive favor by formatting those raw lamports into something human readable.
Which brings us to part 3, decoding base64 account data, translating the payload.
Okay, so running the Solana account command returns a JSON block with a few key fields. You're going to see the lamports we literally just talked about. You'll see the owner, which is the program ID controlling the data. There's an executable, true or false flag. Then the rentEpoch, which tells you when rent is due to keep the account alive. And finally, the somewhat intimidating data field, which is packed with serialized bytes.
Now, I know when people first see that data field, it looks like a completely random string of characters. Please don't panic. It is just base64 encoding. It's not ancient hieroglyphics, I promise. Base64 is really just a safe way to transport raw binary over text systems. It just needs a quick decoding step. But to decode it, you really need the schematic. You need to know exactly what those specific bytes represent.
All right, part 4, real-world program accounts, making sense of the data.
To really make sense of this out in the wild, let's look at the difference between an actual program and an account that merely holds data. If you query an account and see executable true, you are looking at a smart contract. That is the engine itself. But if it says executable false, it's just an account holding state, kind of like your user profile. Basically, it's the cargo that the engine operates on.
I want you to literally sear this rule into your memory. Ready? Always identify the account owner before attempting to decode data. The owner field is basically your decoder ring. For instance, if the owner is the SPL token program, you know exactly which byte layout you need to use. If it's some custom Rust program, well, you're going to need that specific developer's blueprint to map those bytes back into plain English.
Part 5, building your query script, automating the workflow.
Let's be real. Typing out base64 decoding commands manually every single time gets old incredibly fast. So let's act like true engineers and automate the whole shebang. First, validate the input to ensure it's a base58 pub key. Second, fetch the balance and catch any network errors. Third, use a handy little tool called JQ to parse out specific JSON fields. Fourth, decode just the first 64 bytes for safety. And finally, print a nice clean summary to the terminal.
This single bash pipeline you see sketched out here is an absolute lifesaver. We take the data, pipe it into a base64 decode, and then, this is absolutely crucial, pipe it into head-64. Why? Because dumping megabytes of raw binary data straight into your terminal is a surefire way to freeze it up. Finally, pass it to XXD to format it into clean hex. It's just a really quick crash-proof preview.
Almost done. Part 6. Next steps and conclusion. Preparing for transactions.
Okay, so we've built a really solid mental model today. But what do we actually do with it? Well, here are your key takeaways. Always let the owner field define your decoding schema. Choose your commitment level deliberately. Use finalized for absolute certainty or confirmed if you just need speed. And please, rely on your automated script to reduce all those repetitive tasks before doing anything risky.
So are you ready to confidently submit your first transaction? Honestly, knowing the exact rent state, the lamports, and the owner makes you perfectly prepared. Think about it for a second. How could you ever confidently send tokens if you couldn't verify the recipient's wallet state first? You couldn't. This whole process sets us up perfectly for our next lesson, which is submitting and monitoring transactions.
Look, if you can read the blueprint, you can build a machine. Thanks so much for joining this explainer from the Foundry by Forge College. I highly encourage you to go run that script against different program accounts just to see the matrix for yourself. And remember to visit forge.college for tons more Web3 resources. But before you go, ask yourself this. Now that you can see exactly how application data is stored on-chain, what kind of unstoppable engine are you going to build with